All right, in Chapter 11, we've talked a lot about quadratic equations, solving quadratic equations, all different types of things. Now let's talk about graphing quadratic equations. What does a graph look like of these type of equations? Are they lines? Are they circles? What kind of things does it look like if we were to graph these equations? So let's start off with a very basic, what we call parent function, where the coefficient is a 1 and there's no other numbers in my quadratic equation. So if I have the basic quadratic equation, f of x equals x squared, or can I say y equals x squared? Well, let's go ahead and make a table of values so that we can see if we can find a pattern and graph this function. I'm going to pick some x values, just random x values that I can pick, 1, 2, 4, -2, -4, 0. I'm going to plug those into my equation and figure out what the y value that corresponds to the x value is, so that I can find a whole bunch of ordered pairs, and then I can graph what this graph looks like. Let's try 1. If x is 1, I want to plug 1 into my equation. 1 squared is 1, so I end up getting a point at 1, 1. Now let's try 2. If I plug in a 2, 2 squared is 4, and so I know I have a point at 2, 4. If I plug in 4 to my equation, 4 squared is 16. If I plug in -2, -2 squared is 4, so I have a point at -2, 4. If I plug in 4, I get 16, or excuse me, -4, I get 16, and if I plug in 0, I get 0. So let's go ahead and start there and plot some of those points and see if we can find a pattern and graph this equation. I know I have a point at 1, 1. It looks like I have a point at 2, 4. I have a point at 4. Whoa, 16 is going to be way up here somewhere, right? -2, 4. -4, 16, again, way up here. What am I missing? How about 0, 0? Let's even do another one. Let's do -1. Since I've done all the positive and negatives, all the opposites of the other numbers, let's do -1. So if I plug in -1 and I square it, -1 squared is a positive 1, so I have another point at -1, 1. That's -1, 1. You might notice that every time I plug in the positive version of the x and the negative version of the x, I get the same y value, right? And so you might notice that we have a pattern here where if I connect all the dots, I end up getting this kind of a U-shaped graph. It's called a parabola. Anytime I have an x squared, a quadratic equation, it should always be shaped like a parabola. Now maybe that parabola opens up, maybe that parabola opens down, maybe that parabola is fat or skinny or is kind of shifted left or right or up or down. That's going to depend on what other numbers are part of my equation. But a basic x squared graph always has a vertex, that bottom part, at the origin, 0, 0, and kind of goes up like a U. Okay? So the graph of any quadratic is what we call a parabola. The vertex of the parabola is either the minimum or the maximum point, depending on whether the function opens up or down. So in this particular parabola, we have a minimum at the point 0, 0, right? If my parabola opened down, then I would have a maximum as my vertex. So minimum or maximum, depending on what the parabola looks like. Now you notice that the left side is the same exact thing on the right side. We have what we call an axis of symmetry, which is a mirror, where we have a vertical line that goes through this parabola. This vertical line here, whoops, okay, I can't go straight here. Here we go. That's a little bit better. That vertical line cuts that parabola in half. That vertical line is at x equals 0 on this particular parabola. But that axis of symmetry cuts that parabola exactly in half, where the left side should mirror the right side. Now, when we're graphing these quadratic functions, we should always be able to answer a couple different questions. 1, does your quadratic function open up or down? Do you have a minimum or a maximum? What is the vertex of your parabola? Where is that little bottom part or top part at? And then what is your axis of symmetry? From that vertex, your axis of symmetry should slice right through that vertex. And then can we graph a quadratic function, making sure that we have at least 3 points so we can see the pattern, okay? We're going to go ahead and graph a few in a second by talking about what we call vertex form. What happens when we add some numbers to this x squared? What does that do to my graph?